New estimates of snow depth, from a combination of lidar and radar data, improve estimates of sea ice thickness. Arctic sea ice has lost 16% of its wintertime thickness in the 3 years since the launch of the ICESat-2 satellite, and 1/3 of its winter ice volume over the past 18 years. Kathryn Hansen in NASA. In the past 20 years, the Arctic has lost about 1/3 of its winter sea ice volume, according to a new study by researchers at the University of Washington and the California Institute of Technology. That decline is largely due to loss of older, multi-year sea ice. New satellite data also show that wintertime Arctic sea ice is likely thinner than previous estimates. The study was published March 10 in Geophysical Research Letters. The key takeaway, for me, is the remarkable loss of Arctic winter sea ice volume, 1/3 of the winter ice volume lost over just 18 years, that accompanied a widely reported loss of old, thick Arctic sea ice, and decline in end-of-summer ice extent, said co-author Ron Kwok, a polar scientist at the UW Applied Physics Laboratory. Seasonal sea ice, which melts completely each summer rather than accumulating over years, is replacing thicker, multi-year ice. This switch is largely responsible for the sea ice thinning, according to the new research. Arctic snow depth, sea ice thickness and volume are 3 very challenging measurements to obtain, Kwok remarked. The newest technology, a combination of ICESat-2 lidar data and Cryosat-2 radar data, is able for the first time to estimate the depth of the snow on top of the Arctic sea ice. Using snow depth and the height of sea ice exposed above water, the study found that multi-year Arctic sea ice lost 16% of its winter volume, or approximately half a meter of thickness, in the 3 years since the launch of ICESat-2 in 2018. We weren't really expecting to see this decline, for the ice to be this much thinner, in just 3 short years, said lead author Saar Kachimi at Caltech's Jet Propulsion Laboratory. Scientists estimate sea ice thickness using snow depth and the height of the floating ice above the sea surface. Snow can weigh ice down, changing how ice floats in the ocean. The new study compared ice thickness using snow depths from satellite radar and lidar to previous observations of ice thickness and snow depth from climate records. The comparisons show that using climatology-based estimates of snow depth can result in overestimating sea ice thickness by up to 1/5, or as much as 20 centimeters. To provide context for sea ice thickness estimates from 2018 to 2021, the study used an 18-year record of sea ice observations spanning the older ICESat records and the newer ICESat-2 and Cryosat-2 satellites to capture monthly changes in Arctic sea ice thickness and volume. The longer 18-year record showed a loss of about 6,000 cubic kilometers of winter ice volume, or about 1/3, largely driven by the switch from predominantly multi-year ice to thinner, seasonal sea ice. Older, multi-year ice tends to be thicker and therefore more resistant to melting. As that reservoir of old Arctic sea ice declines and seasonal ice becomes the norm, the overall thickness and volume of Arctic sea ice is expected to drop further. Current models predict that by the mid-century, we can expect ice-free summers in the Arctic, when the older ice, thick enough to survive the melt season, is gone, Kachima said.